Students, this question was asked in the year 1997 in IIT JEE. The dimensions of electrical conductivity is. What is electrical conductivity, students? That is denoted by the Greek letter sigma, and this is called electrical conductivity. This electrical conductivity is reciprocal of rho. Sigma is reciprocal of rho, and this rho is called, student, resistivity. This is called resistivity, and resistivity is denoted by Greek letter sigma, and this is also called specific resistance. Okay, student, we have studied about resistance of a conductor in Ohm's law. What Ohm's law states? Ohm's law states that V by I is equal to R. The ratio of electrical potential to that of resistor, that of current, electrical current, is gives us the resistance of the conductor. Okay, student. So R is equal to V by I. And what is V? What will be the dimensions of V? Dimensions of V can be obtained from the concept. See, suppose a charge Q is here at point A, students, and here is point B. The potential difference between point B and point A is V volts. Point B is having more potential difference than A by V volts. Or if A has some 5 volt, this means it is 6 volt. Okay, student? The difference, potential difference is V volt. Then we have to take this charge Q from the lower potential point to the point at higher potential. Then work has to be done, and this work done is the product of the charge into the potential difference between the 2 points. Okay, student? Then W can be written Q into V or QV. So V can be written, student, W by Q. Here we write V as W by Q. And what is W, students? This is work is force into distance. That is, what is force? MLT minus 2, and distance is L. So the dimensions of work is ML2 T minus 2, and that of charge, you know, current I is equal to Q by T, the time rate of flow of charge, or how much charge flows in 1 second gives us the current at that point. Okay, student. Then this is a T, so Q is equal to IT, or we will write here the dimensions of Q as 8T. So students, this becomes M L2 T to the power minus 3 A to the power minus 1. This is the dimensions of potential difference V. So what will be the dimensions of R, students? Resistance R. Let us find out from Ohm's law. V by I is equal to R, or R is equal to potential difference divided by current. So dimensions of R will be dimensions of V upon dimensions of I. Dimensions of V is M L2 T minus 3 A to the power minus 1 upon A. Okay, students. Then this becomes M L2 T minus 3 A to the power minus 2. This is the dimensional formula for resistance. Okay, student. But what is about resistivity? The resistance of a conductor, students, that is directly proportional to the length of the conductor, and that is the resistance is directly proportional to 1 by A. We raise the cross sectional area, or in other words, resistance of the conductor is inversely proportional to the cross sectional area of the conductor. So we may write, students, R is equal to rho L by A, where rho is the proportionality constant called specific resistance or resistivity. So the formula for rho will be equal to R A by L. Okay, student. Then what is the unit of resistance, that is ohm, and here meter square, here meter. So the SI unit of resistivity or specific resistance will be equal to ohm meter. Okay, student. But we are asked what is the dimensions of not this resistivity, that about the conductivity, which is the reciprocal of the resistivity. So let us find out the resist. What is the dimensional formula of resistivity? So we know what is the dimensions of R. So dimensions of rho will be dimensions of R upon dimensions of A upon dimensions of L. What is the dimensions of R, student? That is n L2 P minus 3 a to the power minus 2 into A means L square. Okay, student. L square is the dimensions of area irrespective of the geometrical shape, and capital L in square bracket stands for dimensions of length. This L square cancel out, giving L. So this becomes M L to the power 3 T to the power minus 3 A to the power